So modules is going to be your one-stop shop. And I'm always going to do notes where I'm going to put the date that we did the notes, and it'll say notes, and then what we talked about. So if you click on that 730 notes metric system, here's a link, and it can bring up exactly those set of notes. The same exact thing that I'm going through up on the board, you'll always have access to right there in Canvas. Is anybody having trouble finding that? Excellent. All right. So metric, the metric system, metric means to measure. So this is internationally used. Almost every country in the world uses it except us. And pretty much all of science and engineering and technology uses it. We use it because it's based on the number 10. It makes it so much easier. If you know how many feet are in a mile, there's 5,280. That's not an easy thing to remember, right? Why would we set that up? Well, we set it up hundreds of years ago, and then it just kind of stuck. So scientists essentially kind of created this metric system where it's just based on the number 10. And so everything in this meter stick that I'm holding up on the screen is based on the number 10. This is 1 meter. Here's 10 centimeters, or a decimeter, 20, 30, 40, 50. There's 100 centimeters in this meter. Each centimeter has a really tiny little thing on it called a millimeter. There are 1,000 millimeters, or 100 centimeters in this meter. So everything is based on the number 10, or a multiple 10 times 10 times 10, and it just makes converting so much easier. So length, we use as the distance between 2 points, and the unit we use is the meter. We will make that symbol the letter M. It's really important you know that it's the lowercase m. If you were trying to write like 50 meters and you wrote it as 50 with a capital M, that actually means something completely different from meters. So we only would ever want to write that with a lowercase m if we're talking about meters. That means 50 meters. The other thing I wrote does not. And the tool we use is generally going to be a meter stick or a ruler. Meter sticks are going to be really handy because they have the entire meter. They're much easier often to measure with. Mass. This is the amount of matter. It's kind of similar to your weight, but it's not quite the same thing. If you go into outer space, you have far less weight because you're weightless in space because gravity, but you have the same mass. The mass is how much stuff consists in that object. The unit we use is the gram, and the symbol we use is little g. Same thing, always write a little g, not a big G, just a little g. And the tool we use to measure mass is a balance or a scale. Mass for a solid object is often really, really easy. We just put it on the scale, that's that. Sometimes you might want to take the mass of a liquid. That becomes a lot harder. I can't pour a liquid on this scale, right? It would just go everywhere. So we have another way to take care of that. We can pour the mass, or we can pour that liquid into some sort of container. We take the mass of all of that. So if this was 90 grams, then we dump everything out, we get it empty, we take the mass of just the container. Maybe we found that was 10 grams. 90 grams minus 10 grams would tell me that the mass of the water must be 80 grams. Does that make sense? Anybody confused by that? Area, this is the amount of surface. So how big, you could kind of think about it like, I've got this great big old whiteboard up behind me. How big is the area that it's taking up? You can even look and see, okay, what's the area that the projector is projecting on? How big of a space, how big of a surface is that taking up? And so we do that just length times width. And so here our units are meters, but meters squared. So we often will write that little m for meters and then squared, just kind of like you would in math if you said like 5 squared, where you would put a 5 and then a little tiny 2 up top of it. That's your meters squared symbol. So again, the tool we use is still going to be a meter stick or a ruler. Instead of just measuring one distance, like in length, here I would measure 2. So I can measure, okay, this is about 1 meter tall by maybe about 1.5 meters long. I multiply the two numbers, and that gives me meters squared. So similar to distance, but still a little bit different. And then volume, this is the total amount of space. So this is actually now getting into 3 dimensions. Length is just 1 dimension. Area is 2 dimensions, length times width. Volume is going to be 3 dimensions. Length times width times depth. How much space it takes up. We're going to use different types of units here depending on what we are measuring. For liquids, we're going to use the liter. And the symbol we use is a big L. Little l would be confusing, so make sure, just like mass is little g for grams, little m for meters, volume is big L for volume. Now, what's important is we're often going to use something called a meniscus to measure milliliters. This tool over here is a graduated cylinder. We can use something called a beaker tube. You could use a ruler if we're measuring size. But for a liquid, this graduated cylinder works well. So a meniscus, I use this word. This is an important word, but it can be a little weird to think of. If you notice on the screen, I've got that picture of a graduated cylinder and somebody poured some water into it. Notice the surface doesn't actually look flat. Notice how it kind of curves there? That's because it is. The water, when it reaches the sides, it kind of wants to curl up. So we read something that we call the meniscus. So the meniscus is this lowest point on the water. That is going to be the actual reading. If we read up here at this higher point, that would be completely wrong. This lower point, the bottom of it, I'm showing it up on the screen if that's which one you're looking at. That's going to be the one we read. That's the meniscus. That's what we're going to read. So here I see there's 8 milliliters, here's 6 milliliters. 7 must be in the middle. It's less than 7 milliliters. It's actually 6.246 milliliters. So take a second, try to chat out. What do you think the reading of this meniscus would be? Take a second, see if you can figure that out. Put it in the chat what you think, how many milliliters this would be. Those are all really good guesses. I like them. I am really liking DJ's answer. And I think, Quinte, I think you're headed, and Leah, I think you guys are really headed on the right direction too. Actually, wait a minute. Oh, yeah, DJ, I'll be quiet. You're on the right track. I actually do like Quinte, Leah, Isaiah. I like those answers actually even better. So 35, this would be 35. So this next line would be 36. So right in between, 36 and a half. So that's volume of a liquid. We'll often use that graduated cylinder to figure out how much liquid. For a solid object, like if I wanted to know the volume of this book I'm holding up, there it's a little simpler, where I can just take the length times the width times the height. So again, I would just basically simply measure one side, measure a second side, and measure the third side. I would multiply each one of those times each other. And so the units I would use there would be centimeters cubed. Potentially they could be meters cubed. You can take any length and make it cubed if it's for volume. Now, what if I had something like this? So you can't see it on the PowerPoint, but you can see it on the camera. If I had an object like this, well, this is bumping and jaggy. It's not a liquid, so I can't pour it into something. I'm not going to be able to measure it very easily. We've got a little trick. This is called water displacement. Think about it. If I put a bunch of ice cubes in a cup of water, if I keep putting in ice cubes, eventually it's going to overflow, right? Same basic idea. If I put some water into a graduated cylinder, and then I put my big, weird, round, bumpy object into it, it's going to make that water level rise. And so the difference in those, that would be the volume. So over on the right side of that PowerPoint, you see two different drawings. Let's do the same thing. Take a second, type out a chat if you think you can tell what the volume of this rock must be to make it go from where it was to where it is at the end. Adrian, I like, that's pretty close. Make sure you notice where the first one is, what number is real close to that. Notice it's probably not going to be a whole number. I like those are some good looking guesses. All right, so I noticed right off the bat, it's real close to 5, right? So that's my first step. I'm going to think that this is 5, but I notice it's a little bit over, but it's real close to 5. Then I'm going to come over here. I notice that it's real close to 9. But is it right at 9 or is it actually less? I notice it's going to be a little bit less. So if it was up here, just a little above 9, then 4 would be perfect. If I count up these little tiny dashes, I can see, okay, this is about 5, this must be 5.1, 5.2, 5.3, 5.4, 5.5, 0.6, 0.7, 0.8, 0.9, 6.0. So that means that if I come down, if this is 4, this would be 3.9, this would be 3.8, this one would be 3.7. So 3.7 would be the most accurate reading. Don't worry, there's no way I can really test you quite on these things, because in the real world, next week, we'd get out graduated cylinders and we'd practice a little bit, but obviously I can't give you a graduated cylinder to practice with. And so the very last final unit that we will often talk about in this class is temperature. Temperature, another way to think about it, is something we would call relative heat, because we're comparing the heat of one object to another one. Here we're going to use degrees Celsius. Now this is the one unit where we say degrees in front of the unit, and that's because if you think about it, I can't say that I weigh -5 kilograms, right? That just doesn't make any sense. 0 is the smallest you can be. Well, because in temperature, when people first set it up, well, we knew that you could go colder than freezing water, so that's why we could easily have -degrees Celsius. So that's why we say the word degrees Celsius. Next year, when you take ICP, you might learn a new unit for temperature called the Kelvin, because 0 Kelvin, that's as cold as anything can possibly be. There we don't say degrees Kelvin because it's starting from 0. We say degrees Celsius because we can easily go into -degrees Celsius. And so we'll write a little tiny circle with C. And I can actually show you, if you need, there's a way on Google Docs where you can actually just insert this very symbol, degrees C, to make your life so much easier. And the tool we use then is a thermometer like this. You stick it against or inside the object that you want to take the temperature of to see how hot it is. Now, unfortunately, in this class, we're going to try to stick to the metric system, but because we live in the US, next semester especially, when we talk about weather, think about it. If you go and you watch the weather, they're probably not going to talk about how hot the temperature is in degrees Celsius. They're going to talk about in degrees Fahrenheit. So this is one we kind of have to use both. Degrees Celsius, little circle, big C, degrees Fahrenheit, little circle, big F. Does anybody have any questions on anything in those set of notes? All right, I'm going to stop sharing that. And I'm going to go back to Canvas. So head over to Canvas. I'm going to share a different part of my screen now. So here I'll go back to the home page. And as almost always, we're going to go to modules. And see there at the very bottom of the module is the metric worksheet. So when I click on this metric worksheet, something will hopefully pop up. Now, you might have a screen that says log in. You might not see what I see, and that's okay if you see log in. If you see the words log in on your screen, what you're going to have to do is you're going to have to scroll down, and there will be a little button that says authorize. You have to click on that authorize button so that you get access to this worksheet. So I want everybody to take a minute. I want you to let me know if you're in or if you're having troubles seeing this worksheet. I'm not seeing anybody saying they're having trouble. Hopefully everybody is getting in there. So what you can do, notice on my screen, it's really small and hard to see. Where it says metric worksheet in blue right here, you can click on that and it will actually bring it up in a brand new screen. And that way it's going to be much easier for you to type. You're going to basically get your very own copy of it. Now, an important thing, as you go through and you fill this out, I'm not going to see anything you type unless you submit it. So you're going to have to go back to this metric worksheet. And over on the right side, I don't see one because I'm a teacher, not a student, but you hopefully have a blue button that says submit. When you're done, that's what you're going to hit. You're going to hit that blue button that says submit. So with the rest of the time we have, this is your time to work. If you go, oh, this looks pretty simple, I got this, you're free to go. You're free to leave the Zoom meeting and work on your own. If you think you might need some help, if you have some questions, stick around. You're even welcome to leave and to come back as you need to before the end of class, which is at 9:15. So we got about 10 minutes where you could leave and you could come back if you needed to. So I see many of us are going to go ahead and work. I'm going to stop recording because that's the end of me doing official